All right, so today we're taking a deep dive into something pretty wild. It's a concept called Boltzmann brains.
Yeah, it definitely sounds like something straight out of science fiction.
It does to me too, I gotta say.
But it's actually a thought experiment that physicists use, and it helps them explore some really fundamental questions about the universe.
Okay, so I guess we gotta start with what exactly is a Boltzmann brain?
Well, it's not like there are actual brains floating around in space or anything.
Okay, good, because that would be...
Right, it's more of a hypothetical idea. Like, what if given enough time and enough random particle interactions, a brain could just kind of spontaneously assemble itself out of all the chaos?
Wait, hold on. So you're saying a brain could just pop into existence out of thin air?
It sounds crazy, I know. But remember, this is all theoretical. It's about pushing the boundaries of what we understand about the universe.
Okay, but if we're not talking about actual brains, then why are we even thinking about this Boltzmann brain thing? What's the point?
It's all about what this thought experiment tells us about the universe. It makes us question our assumptions about things like entropy.
Entropy.
Yeah, the idea that things naturally move towards disorder. How a messy room just seems to get messier over time.
Yeah. I know all about that.
But if a complex structure like a brain could randomly form, it kind of throws a wrench into that whole entropy thing.
So it's like saying it's more likely for my messy room to just suddenly clean itself than to stay messy.
That's a good way to put it. It's not that it's impossible, but it's statistically super unlikely.
All right, I guess I'm starting to see why this could be interesting. But how could a Boltzmann brain even theoretically form?
Well, one way is through quantum fluctuations.
Quantum what now?
Quantum fluctuations. They're these tiny random energy bursts that happen all the time, even in empty space.
So even when there's nothing there, stuff is still happening?
Yep. At the quantum level, things are always popping in and out of existence. And some physicists think that under just the right circumstances, those fluctuations could create a brain.
So you're saying these tiny little quantum things could make an entire brain? That's kind of blowing my mind.
It's definitely mind-boggling. But it's important to remember that the chances of that happening are incredibly slim.
Okay, good to know. So are there any other ways these Boltzmann brains could form besides this quantum stuff?
Another possibility is something called nucleation. It's kind of like how bubbles form in boiling water. Imagine similar bubbles of energy forming in space.
Energy bubbles.
Yeah, and under the right conditions, those bubbles could potentially turn into something as complex as a brain.
So we've got these quantum fluctuations making brains appear and disappear, and then these energy bubbles slowly assembling them. It's all a bit much for me to wrap my head around, honestly.
It's definitely a mind-bending concept, but here's where things get even weirder.
Weirder?
What if we ourselves are Boltzmann brains?
Hold up. Are you serious?
Yeah.
You're saying I could just be a random bunch of particles with made-up memories?
It's a question that some cosmologists actually ponder. If Boltzmann brains are more common than normal brains, then statistically it's more likely that we're among them.
Okay, now my head's really spinning. This is some heavy stuff. I need a minute to process this.
I get it. It's a lot to take in. But this idea of maybe not knowing if we're normal or Boltzmann brains, it actually helps us refine our theories about the universe.
So how do cosmologists react to this? Do they think we're all just illusions?
Most agree that if Boltzmann brains were more common than normal brains, it means there's something off about our understanding of the universe.
So it's more of a puzzle to be solved than a straight answer.
Exactly. And there are a lot of different ideas about how to solve this puzzle. Some scientists think we might be missing something about quantum mechanics.
So there's got to be something preventing these brains from forming in the first place.
Maybe. Others believe that a better understanding of the structure of the universe could hold the key. Maybe there's a multiverse.
A multiverse. Multiple universes existing at the same time.
Yeah, exactly. Imagine our universe is just one of many. And in some of those other universes, Boltzmann brains might be much less likely to form.
Okay, so now we're getting really cosmic.
It's all connected, even if it's hard to wrap our heads around.
All right, I think I'm starting to see how this Boltzmann brain idea, even though it sounds completely nuts, can actually help us understand the universe better. It's a tool to poke at our assumptions.
That's the beauty of thought experiments. They let us push the boundaries of what we know and ask these really big questions about existence.
So where do we go from here? How can we figure out if we're Boltzmann brains or not?
That's when things get even more philosophical. If our memories and experiences could be unreliable, then how can we ever really know anything for sure?
Oh, that's a lot to think about.
It is. It really makes you question everything you thought you knew. But even if the idea of being a Boltzmann brain is kind of unsettling, it leads us to deeper questions about consciousness and perception and what it means to be real.
Okay, I need a moment to process all of this.
Take your time. It's not every day you have to question the nature of reality.
That's for sure. So we're just going to leave this existential crisis hanging? Or are there ways to address this Boltzmann brain problem?
There's no easy answer. But exploring the different solutions and theories proposed by cosmologists can help us understand the universe and ourselves better. It's a journey of discovery.
All right, I'm ready to keep exploring. What are some of these solutions? How do we untangle this whole cosmic knot?
Well, one of the most interesting solutions has to do with something called the measure problem.
Measure problem. What are we measuring exactly?
It's not about like measuring distances or anything like that. It's more about measuring probabilities, but in the context of a multiverse.
Multiverse again. Okay, so we're back to the idea of multiple universes with different conditions in each.
Right. And the measure problem is all about trying to figure out how to compare those different universes and like determine how probable they are.
So like, is it more likely for a universe to have stars and planets or to just be a big empty space?
Exactly. And when you're talking about a multiverse with maybe an infinite number of universes, it gets really tricky to figure out which types of universes are more likely.
I can see how that would be a problem.
Yeah.
But how does this measure problem relate back to the whole Boltzmann brain thing?
Some scientists think that if we can crack the measure problem, it might also help us solve the Boltzmann brain paradox.
I'm not sure I follow. How would figuring out the probability of different universes help with the brain problem?
Imagine we have a way to measure universes. And it shows that universes with lots of stars and galaxies are way more probable than universes with just a few random particles.
Okay, that makes sense.
Yeah.
Like we want a universe that can actually support life, not just a bunch of empty space.
Right. And in those universes, teeming with stars and galaxies, it would be much less likely for a Boltzmann brain to just pop into existence.
So by figuring out how to measure universes, we could basically make the Boltzmann brain scenario a lot less likely.
Exactly. It's like we're tilting the scales in favor of the universes that make more sense to us.
That's pretty clever. Like a cosmic balancing act? Are there any other approaches out there?
Another thing we can look at is quantum mechanics itself and how those quantum fluctuations actually work.
Okay, back to the quantum realm. Things always get weird down there.
They do, but they're also fascinating. When it comes to Boltzmann brains, the thing is that not all quantum fluctuations are the same.
What do you mean? I thought they were all just random little energy bursts.
They are random, but they can be different in how long they last and how much energy they have. Some are so short-lived that they wouldn't have time to form anything complex, like a brain.
So it's like a flash of lightning that's gone before you can even blink.
Exactly. Some physicists believe that there might be a limit to how much energy these fluctuations can have, which would also limit how complex they can get.
So maybe quantum fluctuations just aren't powerful enough to make a Boltzmann brain?
It's possible. And if that's the case, then we don't have to worry about those random brains as much.
That's good news. What about that other way Boltzmann brains could form, that nucleation thing? Are there any solutions for that?
Yeah, some theories address that too. One idea is that the early universe, right after the Big Bang, was just too chaotic for those energy bubbles to form and stick around long enough to create a brain.
So it's like trying to build a sandcastle in a hurricane.
Exactly. The early universe was incredibly wild, and it's possible that those conditions just wouldn't have allowed for anything that complex to form.
So maybe the early universe was too crazy for Boltzmann brains.
That's one way to think about it. And as the universe cooled down and became more stable, the chances of those brains forming would have decreased even more.
So we're basically saying that those brains could only have formed during a very specific window of time, which makes it less likely that we're one of them.
Exactly. And that helps to ease some of the worry that comes with the whole Boltzmann brain idea.
I'm definitely feeling a bit less existentially threatened now. But this whole idea that we might be misinterpreting reality is still kind of unsettling.
It definitely challenges how we think about the world. But it's also a reminder of how much we still don't know and how much there is left to learn.
And it makes you wonder, even if we aren't Boltzmann brains, how much of what we think is real is actually just shaped by our limited senses?
That's a question philosophers have been asking for ages. And now with modern physics and cosmology, those philosophical questions are becoming even more relevant.
So we've got physicists and philosophers both trying to figure this whole thing out. Sounds like everyone's having an existential crisis.
It's all about working together to understand the universe. And the Boltzmann brain paradox might seem strange and abstract, but it's pushing the boundaries of physics, cosmology, and even philosophy.
Like this weird little brain is making everyone rethink reality. Okay, so we've talked about a bunch of different solutions to this Boltzmann brain problem, but is there any way to know for sure which one is right?
Unfortunately, there's no definitive test we can do. It's still a thought experiment, a puzzle that we might never fully solve.
So we're stuck with uncertainty. We might never know what's real and what's not.
In a way, yes. But that uncertainty is also what drives us to keep exploring and discovering new things.
So even though this Boltzmann brain idea is a real head-scratcher, it's actually pushing us forward in our quest to understand the universe.
Exactly. It's a catalyst for asking tough questions and looking for better answers.
I can get behind that. What else can we learn from this whole Boltzmann brain thing? Besides the fact that our brains might be figments of the universe's imagination.
Well, one of the big takeaways is that our understanding of the universe is always changing. We're always learning new things. And sometimes those new discoveries challenge everything we thought we knew.
So we're like always adding new pieces to the puzzle, and sometimes those pieces change the whole picture.
Exactly. And the Boltzmann brain, even though it's just an idea, has really shaken things up and made us question a lot of our assumptions.
That's forced us to hit the reset button on how we think about reality.
Right. And that's actually a good thing. It means we're not just accepting things blindly. We're constantly pushing the boundaries of knowledge.
Like we're explorers charting a course through uncharted territory.
That's a great way to put it. And the Boltzmann brain is one of those landmarks that makes us question where we are and where we're going.
So even though it's a pretty weird idea, it's actually helping us move forward.
Absolutely. It's made us think about some of the biggest questions out there, like the nature of existence, consciousness, and reality itself.
Wow. And even if we never know for sure if we are or aren't Boltzmann brains, just thinking about it has been valuable.
It's like this little brain has opened up a whole new dimension of thought and creativity.
I'm feeling a little more optimistic about this whole thing now.
Yeah.
Even if we are just a cosmic accident, at least we're here to think about it.
That's the right attitude. Embrace the mystery and keep exploring.
But I still have one question. If this Boltzmann brain thing is so potentially problematic, why do scientists even bother with it? Why not just ignore it?
It all comes down to the power of thought experiments.
Okay, I'm listening. What's so special about thought experiments, especially one as strange as this?
Thought experiments let us explore ideas that we can't actually test in a lab. Like we can't create a Boltzmann brain.
Not yet, anyway.
Right. But we can use our imaginations and our knowledge of physics to think about what would happen if we could.
So it's like a mental simulation of the universe.
Yeah.
Where we can try out different scenarios and see what happens.
Exactly. And by doing that, we can learn a lot about how the universe might work and identify problems with our current theories.
So the Boltzmann brain thought experiment is actually a really useful tool for scientists.
Absolutely. It helps us push our understanding to the limits and find the weak spots in our models.
And by finding those weak spots, we can then fix them and build a better understanding of the universe.
Right. It's like a stress test for our cosmic theories.
I like that. So we've been talking about all these different solutions to the Boltzmann brain problem. But is there any way to know for sure which one is right?
Unfortunately, there's no definitive test we can run. It remains a thought experiment, a mystery that might never be fully solved.
So are we just left with uncertainty?
In a way, yes. But that uncertainty is also what drives scientific discovery. It keeps us asking questions and searching for answers.
Okay, so even though this Boltzmann brain idea is really weird and kind of unsettling, it's actually been a really valuable journey.
It has. It's pushed us to think about the universe and our place in it in new and exciting ways.
And what's the biggest takeaway from all of this?
I think the most important question we can ask is, what does it mean to be an observer in a universe where even observation itself could be random? What does it mean to exist if our existence could just be a cosmic fluke?
Oh, those are some really deep questions. It makes you wonder what the point of it all is.
It's a question that might not have an answer, but it's a question we're thinking about. It forces us to confront the big mysteries of life and the universe.
It's like this weird little brain has taken us on a philosophical adventure.
And even though the Boltzmann brain paradox might seem strange and a bit scary, it also makes us appreciate the wonder of the cosmos.
Okay, I'm feeling a little less overwhelmed now. It's
Yeah.
like even if we're just a random blip in the universe, at least we're here to experience it.
Exactly. And the fact that we can even think about these things is pretty amazing in itself.
Well said. So what's next? What other mind-blowing concepts are out there waiting for us?
Oh, there are plenty more. The universe is full of surprises.
Well, I'm ready. Bring it on.
Okay, how about we talk about the holographic principle?
Holographic principle. Is that like those 3D pictures on credit cards?
Kind of, but on a much larger scale. The holographic principle suggests that our 3D reality might actually be encoded on a 2D surface. like a hologram.
Wait, are you serious? You're saying that everything we see and feel is just a projection?
It's a pretty wild idea. It basically says that there might be a deeper level of reality where everything is stored on a 2D surface, and our 3D world is just a projection of that information.
Okay, my brain is officially fried. How is that even possible? And what does this holographic principle have to do with the Boltzmann brains?
Well, some physicists think that the holographic principle could actually solve the Boltzmann brain problem.
Really? I don't see how a holographic universe would prevent all those random brains.
It's all about information. If the universe is holographic, it means there's a limit to how much information it can hold.
So it's like a hard drive with a limited amount of storage space.
Exactly. And that limit on information could also limit how complex things can get, which might prevent those Boltzmann brains from forming in the first place.
So there's not enough space on the hard drive to store all the information needed for a Boltzmann brain.
That's a good way to think about it. The holographic principle basically sets a limit on how complex things can be in our universe.
Wow. It's like we've gone from random brains to holographic universes. My brain is working overtime today.
It's a lot to take in, but it's all part of the amazing journey of exploring the universe and trying to understand our place in it.
Well, I think I've had enough mind-blowing concepts for one day. It's been an incredible deep dive, and I've learned so much. Thank you for taking me on this wild ride.
It's been my pleasure. And remember to keep exploring and asking those big questions.
I will. And who knows, maybe one day we'll finally figure it all out. But until then, the journey continues. And on that note, we'll wrap up our deep dive into the Boltzmann brain paradox. Thanks for joining us, and keep those brains buzzing.